Differentiate the following: y equals 5x to the minus 2. You need to remember this. You bring the power down to the front to multiply and subtract 1 from the power. Let's move on to the next slide where we can see we have y equals 5x to the minus 2. We write down dy dx because we're differentiating y with respect to x. Now this is going to equal, we take note of the power, which is minus 2, and that is brought down to here, and it is going to be used to multiply this coefficient 5. So the 5 is brought down to here. Now I'm going to surround that with brackets and return to that calculation in a moment. We now turn our attention to this, x to the minus 2. Now that is brought down, but at the same time we have to remember to subtract 1. In other words, reduce the power. And it's minus 2 minus 1, which we know is minus 3. So we now can write down dy dx equals, if we look to this, it is minus 2 times 5. And 2 times 5 is 10, and minus times a plus is a minus. So that will be minus 10. We now can turn our attention to this here, which is minus 3. So we will end up with this being x to the minus 3, and you can see I'm bringing that down here. So we started off with this, y equals 5x to the minus 2. We then differentiated it to give us this minus 10x to the minus 3. Now, it's not usual to give an answer where the power is negative as shown here. So we can manipulate this a little bit further to get rid of a negative power. And that's what the rest of this video is going to show. So let's bring this to the top of the slide. And what we're going to do is to manipulate this so we get rid of this negative. And to achieve that, I'm going to reflect back on to work on indices. An understanding of indices is important when doing calculus. And the one I want you to consider here is this. If you have got 1 divided by x to the positive 3, you can rewrite that as being equal to 1 times x to the minus 3. And we can further write that as x to the minus 3. In other words, what you can see is this x to the plus 3 has been brought up here, and the sign has been changed to a negative. Now, I'm not going to explain why this is the case. You need to refresh your understanding of indices if this is a bit baffling to you. But essentially, what we have got is this. If you see 1 over x to the 3, there is no sign in this position, and that implies that it's positive. So I can bring this effectively to the top and change the sign to negative. This can also be looked at as being this, that x to the minus 3 is equal to 1 over x to the 3. And again, it's implied there's a positive here. So it's as if you've taken this below the 1 and changed the sign. If you look here, you can see this is x to the minus 3. And here we've got x to the minus 3 equaling 1 over x to the 3. Consequently, I can replace this with this here. So I can write dy dx equals minus 10 1 over x to the 3. In other words, I've replaced this by 1 over x to the 3. I can take this one step further by writing dy dx equals, and you can have minus 10 over x to the 3. In other words, this negative has come down and this 10 has multiplied the 1 to sit on top of the x to the 3. Moving on to the next slide, we can see that y 5x to the minus 2, when you differentiate it, is minus 10 over x to the 3. And we perform this task using the usual general rule for differentiation, but also we had to recall our understanding of indices. And my message is, if you don't understand indices, I would suggest you stop studying calculus for a little while and go back and firm up your understanding of indices, as I will be making assumptions that you understand indices in the videos I do on calculus.